Hello and welcome back to this series on neural networks for the purposes of the digital humanities. In the last video, we looked at TensorFlow, what it was, and the basics of how to install it. In this video, we're going to take a look at the API, or the programming interface, that works over top of TensorFlow, known as Keras. And I'm going to be using primarily in this video an excellent blog post that we see right here. And I'll provide a link in the description down below that goes through and looks at Keras, TensorFlow, and PyTorch and kind of compares them all and talks about the strengths and weaknesses. So TensorFlow comes out of Google in around 2015 or so. It's open source. They put it out there so that other researchers could actually harness the same kind of software and frameworks that they were using internally. That's where TensorFlow comes from. Shortly after TensorFlow goes on the market, and remember, TensorFlow is used for the mathematical operations for the purposes of performing machine learning. When TensorFlow comes onto the market in 2015 or 14, immediately an individual, a researcher named Francois Chalet, comes out with Keras. And Keras is a neural network library written explicitly in Python. If you remember from the last video, TensorFlow is written in C++, which makes it very quick and very efficient, but it also has the ability to be accessed via Python. The difference here is that Keras is a Python-specific library that can be easily pip installed. In 2015, Francois Chalet puts out Keras, and along with his book Deep Learning in Python, in which he walks users through step by step how Keras works, how it can be easily used by those who do not have a mathematical background, such as humanists, even though he doesn't use specifically that terminology. And this makes neural networks really kind of for the first time accessible to a wide audience. This kind of the coming out with TensorFlow as a framework, and especially the coming out of Keras as an API for TensorFlow. At the same time, other frameworks are coming out as well. So PyTorch is put out by Facebook's AI team. Again, it's also open source. In this video, I'm going to kind of talk about the strengths and weaknesses of all these different frameworks and why in this video series I'm kind of sticking with Keras and TensorFlow. So let's kind of jump right in. And again, a lot of what I'm going to be talking about here is kind of a summary of this blog post. And again, I'm going to provide a link in the description down below. So TensorFlow and PyTorch are both far more efficient and far quicker at deploying neural networks and training neural networks. And the reason is because of the way they're designed. Keras is much slower. So why do I use Keras? I use Keras because it is relevant to all Python libraries, very efficient and easy to write. It's easy to read, it's easy to code, and oftentimes as humanists, we don't work with giant data sets. We oftentimes work with smaller data sets. And when I say smaller data sets, I'm talking about relatively smaller data sets that might consist of 20,000 to 100,000 data points. With big data, you're looking at millions. And so for big data, TensorFlow and PyTorch are typically preferred because they're far more efficient, TensorFlow being written in C++. But for our data sets, Keras, the time exchange, and the ability to code quickly and learn quickly make Keras kind of the easier and more obvious choice for digital humanists. And that's why I'm kind of using it for this series. And it's also got a new edition coming out for the book on Keras, Deep Learning and Python by Francois Chalet. And that new edition is being published online chapter by chapter as it's being completed. And I'll provide a link in the description down below to that book. And I think for that reason, you can also find a lot of benefits from Keras in the future as well, after the publication date of this video, which will probably be September 2020. Now, if we keep on going through, we've already talked about the fact that Keras is slower and why Keras, despite being slower, is good. But a really great way to think about choosing a framework is kind of problems that you might encounter. This is known as debugging, and for this reason, PyTorch is a little bit easier to debug. But if we look at this chart here, we see that in popularity, there is no doubt that kind of Keras is dominating the field, followed by TensorFlow, followed by PyTorch. They're all slowly kind of going up, but it is certainly clear from this chart that Keras and TensorFlow are much more preferred by the community. And if I were to guess, I would guess that if you were to look at this by humanists who are actually using neural networks and implementing them, we would see the data skewed even more in favor of Keras. But what's really good, I'd recommend going to the site and kind of just looking at the general final verdict. It's a very easy read, very short, but it kind of summarizes a lot of the findings. So you might use TensorFlow if you are using large data sets, if you're seeking performance, if you're seeking functionality, if you're doing something like object detection, which again, as humanists, we might not really be doing. The reasons why you might want to use PyTorch is because of its flexibility, its short-term training duration, and its debugging capabilities. But really the reason why as humanists we should really consider Keras comes down to the fact that you can do rapid prototyping. So you can develop a neural network, if you know Keras, in a matter of minutes. And you can train very, very quickly right out of the gate. It's really good because we oftentimes work with these smaller data sets, relatively speaking, and because that the time difference in training between Keras and TensorFlow is so great, but because our datasets are so small, it makes that exchange relatively minimal. And also, it has multiple backend support. What's nice about Keras also, if you're watching this video in 2020, is that now Keras comes standard with TensorFlow. So originally, Francois Chalet developed Keras independently of TensorFlow, and it was designed to work on top of it. Now, TensorFlow has fully adopted Keras, and this is why that second edition that's going to be coming out on deep learning and Python is particularly interesting, because the first book was published in 2015. This new book, which will be published hopefully by the end of 2020, will actually incorporate a lot more of that, the new advances in Keras in the past 5 years, as it's been incorporated explicitly into TensorFlow. So that's all I'm going to mention in this video about Keras and why we particularly should consider using it in the digital humanities. If there is a difference of opinion, please let me know in the comments down below. I view this channel as a way for us to kind of talk and share ideas, so please do, if you want to challenge this idea, do so in the comments. I have no problems with that whatsoever. That's going to be it for this video. Thank you for listening. If you join me in the next video, we're going to start actually getting into part 2 of the series, in which we explore text classification. And we're going to do this over the series of videos. The first one I'm going to do is just talk generally about the shallow neural network architecture that we're going to use to solve a binary text classification problem. And then over the course of the next few videos, as we see 11a, 11b, 11c, 11d, 11e, we're going to go through and state the problem very clearly, a binary text classification problem, what it is, what it might entail, and why a neural network is particularly suited to solve it. Then what we're going to do is we're going to go through step by step in the process. In most Keras tutorial videos, they use the standard IMDb datasets, or they use the ones that come stock with Keras and TensorFlow. These are great, but they don't really do a lot for us as humanists, because our problems are very much different from those of the data science world generally. And so what I want to do in this series as we go through is show you how to acquire the data, how to prepare the data, how to prepare the model for training, how to train the model, and test the model. So take you through the entire process from acquiring the data to cleaning and preparing to actually using the data, and then using the neural network to actually have some real world result. The case that we're going to look in binary text classification is a model that can separate Oscar Wilde from Dan Brown. But if you stick with me through that series, I think you will find that you can take the skills that you learn and apply them to your own independent research. That's going to be it for this video, though. Thank you for listening, and if you've enjoyed this video and you're looking forward to the part 2 of the series, please like and subscribe down below.